Good afternoon, everybody. It's Sterling Hafey. I'm back with another Teach It. Today we're going to be doing Chapter 13, Teach It, Section 5, Section C of the homework, question number 20. So our objective here in this question is to find the perimeter and the area of two specific shapes. Those shapes will include an ice cream cone looking shape, and a semicircle. However, both these shapes have some different variability between them. The ice cream cones we've been cut off here and cut off here. So we've got two right triangles underneath a semicircle. The radius of that semicircle is 6 centimeters. And then this value is given is 8 centimeters, the height of that triangle. So those are our two given values. On this one, we've got a semicircle. However, we are just trying to find the area of the shaded region. And these lengths right here, 20 centimeters. 20 centimeters. So based off that, we can see, we're just trying to find the shaded region. On this one, the area and the perimeter, and the area and perimeter of this whole thing right here. So first, we'll start with A. We'll go with trying to find the perimeter first. No, the area first. All right. So first, we'll start with the triangle. Triangle seems pretty easy to do. So we've got a radius of 6. So these are equal right here. So the whole base is going to be 12. Now the area of a triangle we know is the area of a triangle is half times base times height. So by that, we can see, so that we've got a base, so we're going half times a base of 12, and our height is our given value of 8 centimeters. So we get half times 96, and then half of 96 is 48. So we've got 48 centimeters squared. That is just for our triangle portion. Now, for the semicircle portion, we've got to find the area of a circle, we know, is equal to pi r squared. So pi r squared is for a whole circle. However, this is half a circle. So we're going to divide that by 2. So because of that, we've got pi times the radius, which is 6 centimeters. 6 squared, still all divided by 2, which then we plug and chug. We've got 36 pi over 2, which is then equal to 18 pi. So we're going to keep this like an exact answer, so we don't want to multiply the 18 pi. So our area is equal to 18 pi plus 48 centimeters cubed. So there we've got that. Now, we've got to find the perimeter now. So that's going to include finding the circumference of this part, and we've got to find these angles. So because these are right angles, or because these are right triangles, for the triangles to find this angle, or this side, we can use the Pythagorean theorem. So we've got a squared, which is 6, plus b squared, which is 8, equals c squared. Now, these two values, we've got 36 plus 64 equals c squared. This equals 100. So square root of 100 is 10. So c equals 10 centimeters. So this is 10 centimeters, and this is 10 centimeters. So now, we've got those two sides. Now all we've got to figure out is the top of the ice cream cone right there. So now we've got to find the circumference of the circle. The circumference of the circle, we can all see that, so circumference is 2 pi r, which in other terms could be pi times the diameter. But so in this fact, that's for a whole circle. Now, for just a half a circle, we're going to divide it by 2, because we've only got to worry about that. So inevitably, we get circumference equals pi r. Now, our radius we know is 6 centimeters. So our circumference is going to be 6 pi. Now, put that all together. The perimeter of the ice cream cone shaped deal is going to be 6 pi plus 20 centimeters. It is 20 centimeters because we've got 10 centimeters plus 10 centimeters. Now, that is part A. Now, let's get to part B. So, now we're just trying to find the area of the shaded region. But first, we're going to find the perimeter. It seems a little bit easier. So, we've just got this part to worry about. Now, first, so we know, again, the circumference of a circle is 2 pi r. Again, we're dealing with a semicircle. So we're going to divide that by 2. We've got the circumference equaling pi r, just pi r. Now, the circumference of it, we're not worrying about this side because only this is the shaded part. So, by doing that, that means we are completely wiping out that bottom side. So our radius is 20 pi, and just like that, we've gotten our perimeter of that. Nice, quick, and easy. Now, so that is the 20 pi centimeters is the perimeter. Now, the area of each circle. So first, we want to find the entire area of this semicircle, and then we can subtract each smaller semicircle and find the complete area. So for each smaller semicircle, the area of the smaller circle, we're going to go pi r squared. So we've just got a smaller square. We know we're going to divide by 2. We've done a lot of that today, so a lot of semicircles. So we've got divided by 2 equals, so cutting 20 in half for the radius will be 10 centimeters. Then we've got pi times 10 squared divided by 2. That is going to equal 50 pi. So these are both identical. So 50 pi times 2 is going to be, kind of works as one whole circle. All in all, is going to be 100 pi. Now, so we've found the area of those. Now we've got to find the area of the big circle. So we know, again, a semicircle. So the area, pi r squared, divided by 2, since we're dealing with, of course, another semicircle. And we've got a radius of 20 centimeters. So we've got pi 20 squared divided by 2. 20 squared is 400. So we've got here 400 pi divided by 2, which equals 200 pi. Now, 200 pi minus the 100 pi that were in here, we've got 100 pi centimeters squared. So that for part A, we found that the perimeter was 6 pi plus 20 centimeters. The area of the ice cream cone shape was 18 pi plus 48 centimeters squared. And for part B, we found that the perimeter is 20 pi centimeters. And for the area of the shaded region of the semicircle, we found that it was 100 pi centimeters squared. Thanks for joining me. Sorry it took a little bit longer this time. Have a good day.